Baku, Azerbaijan is a host city for the International Astronautical Congress to be conducted this October by our friends and partners at the IAF. As our panel comes to the stage, please enjoy this brief video from Baku.
It all started centuries ago, with Nasreddin Tusi contemplating the celestial bodies in search of the unknown. Ever since, our innate desire to explore space has only been igniting. We were the first and only in the region to host the International Astronautical Congress. We embraced space knowledge to harness its power, and even ventured into space. Today we continue our journey, designing solutions for a better connected and secure world. We inspire the next generations to look for new horizons, explore, create, and innovate. And once again, we are bringing space community back to Baku, Azerbaijan. A place that offers cultural immersion and unforgettable experiences. From ancient palaces to the pearls of contemporary architecture, to spectacular sceneries, everyone can find something of interest here. The people and the hospitality, rich culture and traditions, unique arts and crafts. And the delicious cuisine will leave you in awe. Discover the spectacular facets of Azerbaijan and indulge in the celebration of everything space in Baku at the International Astronautical Congress in 2023.
Testing. I always struggle with pronouncing that name, so I'm glad I got it right this time. But our next panel features an impressive lineup of NASA Associate Administrators to discuss the Moon to Mars strategy. And we are delighted to welcome back to the stage Deputy Administrator Pam Melroy to lead the discussion. Ms. Melroy, the stage is yours.
Oh, thank you, Max. Thanks for the introduction. Thanks. It's great to be here, and I'm really excited to be joined by our senior leaders of the mission directorates. At NASA, there is an invisible sixth chair, which I will talk about in a moment. But first, I'd just like to say how excited we are about the Moon to Mars strategy and the steps that we have taken. The release yesterday of the architecture concept review documents. You've all had 24 hours. You've read all 150 pages and all the white papers, I'm sure. Well, I'm hoping you are, but we look forward to your feedback on that. But we're going to unpack and go a little bit level deeper. But I think the most important message that I want to send today is that this is a whole of agency strategy, and it's very important to understand that. The invisible sixth chair I referred to is our Aeronautics Directorate. Now, Bob Pierce, the head of Aeronautics, didn't have very many meetings here at the Space Symposium, so he didn't join us, but I can tell you the presence of the Aeronautics Directorate is vibrant through the Federated Board and through the partnerships between all of our mission directorates. It's my real honor to introduce to you our senior leaders that we are so incredibly proud of all the work that they do. I'll start with Ken Bowersox, who is the Deputy Associate Administrator for the Space Operations Mission Directorate until the end of the month when Kathy Leaders retires, and then he will be taking over as the leader. Next to him is Dr. Nicola Fox. Nikki just was installed as the head of science at NASA. Next to her is Jim Free. He's the Exploration Systems Directorate Associate Administrator. Next to him is Bob Gibbs, the Associate Administrator of our Mission Support Directorate. And then finally, Jim Reuter, who is the head of our Space Technology Mission Directorate. Would you please welcome them? So I'm going to get right to it. I would really like them to unpack what the Moon to Mars strategy and its implementation means inside their mission directorate. And of course, I'd like to start out with Jim Free. Tell us about the ACR, that architecture concept review. What does that mean for the Artemis program with hardware in work today and those still in formulation?
So the architecture concept review is going to be an annual process that we are going to go through to plan our both near-term and far-term missions. So the first instantiation of that involved all of the mission directorates, all of the center directors, all of our technical authorities to really define our near-term missions. If you think kind of 2 through 4, 2 through 5, or we call it the human lunar return, so that we now can start to plan our longer-term missions as we look at the tie back to the objectives that the agency put together last year and into this year, to show how each mission is set up to achieve those objectives. So that human lunar return that I mentioned has obviously our near-term hardware. As we look at the next set of missions, we can start to define what are the other hardware elements that we might need. What do we need to do our #1 priority, which is science on the lunar surface? So for us, it sets both a near and long-term roadmap for exploration, either robotic on the moon through the Science Mission Directorate, advancements in technology, partnerships with our Space Operations Mission Directorate, so that now all of us agree on what our missions are, both near and far term, with the eventual goal of Mars. So our next architecture concept review will be this November, and then every November thereafter. And we'll set this November a large focus on Mars to kind of backdrive what our next set of lunar missions need to do with our goal of always heading out towards Mars.
Thanks, Jim. I'd like to go to Sox next. If you would talk about what we're doing today in low Earth orbit, our current human spaceflight missions to the International Space Station, and some of the commercial LEO work we're doing, how does that support the Moon to Mars strategy and objectives?
Well, it's hard to believe that over 22 years ago, we established human presence in low Earth orbit aboard the International Space Station. It's still amazing to me that it's been over 2 decades that we've had humans continuously flying there. When we started building the station, the idea was to have a laboratory in space where we can increase our knowledge about the processes that affect us every day and bring benefit back to Earth. We also intended to gather knowledge about the performance of the human in microgravity that would inform future missions to Mars. In addition to those 2 categories, we built a lot of hardware, we assembled it, and people focus on that, but while we were building that hardware and assembling it in orbit, we were also building a very complicated partnership. A partnership that, again, will carry us beyond low Earth orbit, out to the moon, and onto Mars. But every day now on Space Station, we continue that work to understand what happens to humans in microgravity. We continuously do that science to bring benefit back to people on Earth. And we're also developing these new markets for crew, cargo, transportation, all the things that will help us as we build capability to someday go beyond low Earth orbit.
Well, I agree with you. And for those who don't know this, Sox was one of the early commanders of the International Space Station, one of the early commanders of a multinational crew, and starting the science priorities on ISS, so he knows whereof he speaks. So thank you. That's wonderful. Nikki, science, front and center, needs to be front and center in our Moon to Mars strategy to support what we do for the American people. Can you talk a little bit about how those priorities are going to get integrated from CLIPS all the way through the human missions?
Absolutely. Sorry. I'm just going to take some water.
Been working too hard, Nikki.
So we really think that science is front and center all the way through the Moon to Mars. And yes, I have a really bad cold. And we see ourselves really sort of playing a big role in both tenets 4 and 8. My favorite one, of course, being number 4, the maximizing the crew science for the crew. But, you know, I think about the science in terms of the different stages. So there's the science that you can do on the way to the moon, kind of as we're journeying there. And we're already doing amazing science on the ISS. You know, clearly looking at all the human research we're doing, the quantum computing, the things that you can only do in low gravity and zero gravity areas. We also also take advantage of the ISS to put out external payloads, and we have those for astrophysics, heliophysics, and earth science. And you probably all saw these amazing images from EMIT last year when they actually detected methane sources, and they was only able to do that because of having that position on the ISS. And then looking forward, obviously, to how we transition to the commercial LEO destinations also. But then, you know, with Artemis, so taking the next step to the moon, we had Bioexperiment 1 on the Artemis 1 mission that actually looked at the effect of radiation on seeds and algae and fungi, and you know, so that was already on there. We had 3 successfully deployed CubeSats, and then earlier this month we had nearly 400 scientists that got together to really study the 13 landing sites, to start thinking about what can we do, what are we going to find out when we get to those sites. So it's really great. And I know I've only got 5 minutes, but I'm going to use them all. But then there's the science that you can do, like studying the moon. And we've done, obviously, so much already. Looking forward to Gateway getting up there, and we're going to have external payloads on Gateway that are going to help us study cislunar. But we're, you know, really excited about our CLIPS program, landing NASA science, partnering with our commercial partners, but actually landing NASA science on the moon. We've got 2 coming up this year. One that will study, you know, just like the effect of space weather on the lunar regolith, something I'm really interested in. And then the second one that will actually land a lander and then have a little hopper that goes in and out the shadows. We're really excited about that. And then I would be remiss if I didn't mention, we would also like to study the sun. You know, we can study, it's a unique ability as we ride with Artemis to study the various different, the solar wind. We can go into the pristine solar wind. We can study the magnetosphere. But the cool thing that can only be done on the surface of both the moon and Mars is to study the ancient sun, to go down into the regolith and look at what the sun did to those surfaces. And then, you know, finally preparing for science at Mars. I mean, we've done so many amazing things at Mars over the last 20 years. You know, I mean, just look at all the rovers, the landers that we've put on Mars, now getting ready to bring samples back. So, I just think for science, we're going to take advantage of every single opportunity that Moon to Mars offers us, and we're there for you, Pam.
Well, that's great, and I'd like to remind everyone that the decadal studies are really your anchor. Granted, we're looking at more than 1 decade, but if you look at the objectives document, you will see as one of the appendices is a mapping of all the objectives, the science objectives, to priorities out of the decadal. So that is an integral part of that plan.
Yeah, and actually for the heliophysics decadal, we actually have Artemis as one of the opportunities that will be exploited. So really looking forward to that.
Good. Well, appropriate to talk about a little extra about science, considering the importance in the Moon to Mars strategy. So I'd like to ask Jim Reuter next. What are some of the key technologies that STMD is working on that are going to be essential in the Artemis and Moon to Mars program?
Yeah, thank you, Pam. What I think I'll do to answer that is talk in terms of 3 categories. The first category is advanced space transportation. Revolutionizing how we get around and operate in space is a critical factor. Now, we're a technology office, so we don't develop things that are full flight for missions necessarily, but we do develop the technology in front of what ESD or SMD or somebody else would adopt. And in that category, I'll just mention 3 areas. The solar electric propulsion system that is on the power and propulsion element, 13 kilowatt units. Those are things that we've developed over time, and we're entering qualification of the unit now. As well as flight build. Cryogenic fluid management, we've a large investment right now with 4 different long-term storage and transfer of cryogenics in space. That is critical for us to really navigate the entire universe, as well as on advanced landers for the moon. And then also nuclear. Really, if we want to be transformative of how we get around in space and how we can prepare for Mars, nuclear propulsion is the way to go. And one of the things that we just recently announced jointly with DARPA was a co-development of a Draco project. with the target of flying a demonstrator unit for nuclear thermal propulsion in the late 2020s. The second category I'd talk about is lunar surface infrastructure, part of one of the key elements of the Moon to Mars objectives. And with that, it's the things you would think about. Also on the technology side, like power and power distribution, a variety of activities that we have going on there, like vertical solar arrays, regenerative fuel cells, and fission surface power for the Moon, more nuclear reactor. COM, PN&T, for those places where technology is needed, we'll do there. And in situ resource utilization, recovering water, oxygen, and minerals and metallics from the regolith of the Moon. The third category I talk about is what I might term cross-discipline activities. These are things like robotics, assembly, servicing, autonomous operations, mobility. These are critical technologies and activities that we have for not just lunar surface activities, but cislunar space, and really government and commercial wide. These are things that are just all needed for that. And so in keeping that in mind, what we'd like to announce, I'm excited to do so, is that we're forming a consortium in this area. It's called the Consortium for Space Mobility and ISAM in Space Servicing, Assembly, and Manufacturing, and ISAM Capabilities, or COSMIC for short. We're establishing this as a nationwide consortium coalition to invigorate ISAM efforts in the U.S. And it's really, we take its heritage from the Lunar Surface Innovation Consortium, which is, the objective of that is to really get a community together, sharing information, sharing ideas, and understanding better of what's going on. It's worked fantastic there, and we're really anxious to put it on here. Our goal for COSMIC is to accelerate the universal adoption of ISAM capabilities, to develop the next generation of the space architectures, and make ISAM a routine part of the space enterprise. It is a response, our response to the December 2022 National ISAM Implementation Plan, and we officially are kicking this off this fall. The consortium is managed for us by Aerospace Corporation, which has a wide reach across government in this area in particular. And if you want to learn more about this, I'll mention a couple things. First, going live today is our website. It's cosmicspace.org. The second thing I'll say is at 3 o'clock today, it's a little bit tight after this, but Trudy Cortez, who leads this for us, is doing a tech talk over in the NASA area of the exhibit hall. So, thank you.
Thanks, Jim. I am so excited about this consortium. As you know, we started talking about this shortly after I came on board, and I'm thrilled about this announcement. I think it is really important to bring the community together, especially around something so important as ISAM. So, which of course, you know, I'm a big proponent of, so I'm thrilled about that. So next I'm going to turn to Bob Gibbs, and I'd like you to tell us all about how the Mission Support Directorate's role is evolving to support this long-term strategy.
Thank you, Pam. Thank you for the question. First, I'd like to take a moment and reflect on how cool it is that we're sitting here, all in this room together, talking about going from the Moon to Mars and beyond. And just take a moment and think about how cool that is. I think everyone here hopefully can see themselves in it. This architecture, these goals, this objective, these are incredibly important, first to our workforce and to our partners, most of the people in this room, to our stakeholders across the globe, because we're talking about where we're going and why. Our employees can see themselves in it. This is an incredibly important step, and how important this is, it can't be overstated. So I think that's incredibly important. It also allows us to start looking at all of the mission support needs. Our job is to support the mission, so we can talk about all of the long-term implications of this architecture, these goals, these objectives. So we can talk about the infrastructure that's needed. We can talk about the people, the knowledge, skills, abilities, and capabilities to help support this mission as we deliver it. The acquisition principles, how we're looking at doing contracts and partnerships, and all of the things that bring all of the things in mission support every day together to help support the Moon to Mars architecture is informed by what's going on. So like I said, I think this is an incredibly important thing that you can't say enough about.
Thanks, Bob. The mission support functions are the glue that hold us together at the agency. So we really appreciate everything you're doing to support our technical strategy.
Thank you.
So speaking of technical strategy, I'm gonna pick on you again, Jim Reuter. You've talked a lot about technologies, but one of the things that we hear, we're trying to address is what are the things that we need to go out into the solar system to develop a blueprint for sustained human exploration? What are the challenges? Why are we doing these things? What are the hard parts? And how do those technologies address those hard parts?
Yeah, thank you, Pam. And I really kind of thought that being this far down, I might not be noticed as much by you. But I'm happy to. I'm happy to actually receive the question. Thank you. And what I'd say is, a big part of what we do is it's a blend of activities of things that are solving relatively nearer term being still several years, activities for Moon and the sustainable presence for there, and helping enable and understand the technology gaps that we're dealing with. But also then, it's a real challenge to go to the next step and go on to Mars. And for the activities for Mars, it seems like it's a long ways off, okay, but the problem with it is if you don't start now, these are technologies that need 15, 20 years of development as they go through there. And so we need to find creative ways to go and address that. The nuclear propulsion, the nuclear fission surface power that we're working with, as well as landers. And if you noticed, don't look today anymore, but if you noticed out on the pond, there was a big orange thing. Well, that's actually an inflatable decelerator, a mock-up inflatable decelerator that we demonstrated successfully last November, as a way of landing very large structures on a mass of activities on a planet, either Earth, Mars, that has an atmosphere and stuff. So those are all critical technologies that we have to do. But what I find out is if we have the right people with the right incentive and a funding able to do the funding, we can solve all those problems. So my biggest challenge ends up being, how do we balance things? How do we balance between the things that we should do near term versus having a strong development project for longer term? How do we balance between what do we do with academia versus industry? How do we balance our acquisition approach for addressing these things? What intellectual property versus pushing for and enabling innovation as we go through it. So that's actually my biggest challenge area.
Well, you've shown a lot of leadership in that area, Jim, so I appreciate it. And you're right. We do have to balance that. I'm proud of the work that you do, though, because I think we're leading the way in partnerships and thinking those things through. So thank you for doing that. It's critical, seed corn for the agency, right, for an analysis of alternatives for our Mars technologies in the next decade. All right. Let's see. Let's go to Bob. So what opportunities does having objectives and a strategy in place open up in your area? And how's that going to get us all to the next level?
That's a great question. So when you talk about workforce and infrastructure and a lot of the things that we do, it gets a little controversial sometimes. So if you have any concerns, if you have any thoughts like that, please feel free to send them to me at jim.free@nasa.gov. So, anytime, day or night, just send them in. Just keep it all coming in. I think it's really a conversation. I had to do that, Jim.
That's good.
Yeah. It's really a conversation about perspectives. These objectives allow us the opportunity. We're all operating in a constrained resource environment, right? But increasing requirements, constrained resources is an incredible challenge. But from my perspective, this is an opportunity. This is an opportunity to find ways to reinvent our business, to develop those business models to support the agency, not only today, but as we go forward. And if you're going to make a challenge, if you're going to bet on an organization to rise and answer a very difficult challenge, I'll place my money on NASA every single time.
All right. Awesome. Fantastic. Jim Free.
Yes, ma'am.
Now that your email address is out there. So, we talk about this all the time, but I think everyone will really appreciate hearing from you how Artemis and our future lunar and Mars missions have seen the directorates all work together, including our invisible sixth chair. It's really quite extraordinary to see how well everyone has worked together and contributed key aspects to the strategy and taken ownership of the pieces that your directorate leads. For you, Jim, though, as the person who is tasked with building the architecture and executing the missions. How do you see this continued collaboration unfolding in the upcoming Artemis missions as well as the ones beyond?
Well, the collaboration just changed a few minutes ago. You know, I think Artemis, if I start with Artemis 1, I think we've already proven it, and folks that came before me in this role proved it as well. We all came together to really solve a bunch of problems to get that first mission off the pad. But one thing that went beyond the problems is what we did as a group, right? We handled it as a management team. We had science on the first mission. Our space ops folks were tremendous in our support with SCAN. I think we only build from here because with science at the front and center, as Nikki said, we're all here to do the science that you need. We're aligned to bring technology on future missions and into the architecture. We depend on the infrastructure that Bob puts together to support our workforce. That is essential to what we do, to work with our partners. And speaking for my mission directorate, the planning side of it is we are all doing this together. And I started with the ACR. I mentioned who sat around, who bought into it. I saved the emails where I reached out to each of the mission directors before we went to the executive council to say, are you okay for us to go to the executive council? And that included the center directors, the technical authorities, and I saved all those emails that said, yeah, we're ready to go. And that's the first time in my 30 plus years around the agency that I feel like we are that aligned and that bought into the plan. So for me, the collaboration started on one, and we've set just a great precedent going forward.
Terrific. Yeah, I agree. It's really extraordinary to see, and I think we really need to do that. The complexity of what we're doing is so much greater than anything I think we've ever attempted. To see everybody working together well is just, it's really wonderful to see. And that was one very important reason for having this panel. So I think I'm going to go to Nikki next to talk about one of the very critical aspects of our Moon to Mars strategy and how we hope to implement that. And that's our international and industry partnerships. As you know, this is very different than what we did in Apollo in the nature of those partnerships. And that's a critical part of going the distance, is to have key partners. How do you think that's going to evolve to support a strategy that can be resilient for 20 years or even longer?
Yes, I mean, I think that certainly our international and our commercial partnerships are evolving all the time, but I think now they're evolving quicker than ever, which is really great to see. But even if you look back, look across the entire science mission portfolio, it's almost hard to find a mission that doesn't have international participation or commercial participation, even if, whether it's organically through the science teams or whether it's intentionally through, transfer of technology. So, we really enjoy and embrace our partnerships with all of our agencies. But, I think looking forward, as I said, I think it's going to really evolve quickly. And even just looking in the next year, we have, I already mentioned the CLIPS launches, but we'll have the first 2 of those, so really good partnership with industry. And then coming up, we have JAXA's Smart Lander for the Moon, the SLIM mission that will launch, and we have ISRO's Chandrayaan 3 that will also launch. So, there's examples all the time of these really great missions, and collaborating internationally is just wonderful. And then we're really excited for the evolution of ISS. I mentioned the commercial LEO destinations, but really taking part in the commercially enabled rapid space science initiative, the SIRIUS initiative. Our biological and physical science is really interested in working with that part. They're actually also looking forward to their decadal. You mentioned the decadals, and they actually have a focus on how to work with those new commercial low Earth destinations. And so I think, over the next 20 years as well, I really think that we're leading the way with our Open Science initiative. The 2023 is the year of open science, but really making science open and usable and accessible for everybody. You know, not just it's usable as long as you have a VAX cluster, but it has to be useful. You have to use it. You have to be able to use it. So how do we lower the boundaries for everybody to come in and take part in NASA science, but take part in the excitement of the moon to Mars? And so, you know, I think with our internationalization and our sort of the science and the commercialization of the techniques, I think that together, you know, NASA and all of our fellow agencies will just do amazing things and, you know, explore the Earth, go from the moon to Mars and beyond.
I agree. I have to say some of the partnerships that I'd love to highlight. I know that NASA is now the largest purchaser of commercial remote sensing data to provide to our scientists. And recently, some NASA scientists landed on the front page of Nature with work that they did solely from commercial data sources. And then I know we probably have some of our great international partners here, and programs like SWAT that we're, you know, partnered with Kenneth and others is very, very important to us. And I think we'll do more of that. This is really near and dear to my heart. The industry partnerships, I think we're really modeling and innovating the way we did with Commercial Crew and Commercial Cargo. We're looking very seriously at, you know, how we make decisions about partnerships. Jim, you mentioned IP and the importance of understanding IP. It's also about, are there many other customers for this capability, or are we the only customer? And we think about that for our industry partnerships. And for our international partnerships, it's really critical that we go to space as humanity, not as just one nation. We need to go with our partners. And so the Artemis Accords are a way for us to structure and frame some of the principles that we all agree to that help us take the next step beyond the Outer Space Treaty. But even beyond that, what I'm excited about is partnerships with countries that are just beginning on their space journey, and the opportunities that the architecture offers, not just in, you know, multi-billion-dollar things, which of course we need and will be crucial parts of the architecture, but also to contribute to our science objectives. And you've been pioneering, working with many nations from a range of experience and capability for years. So thank you for that, Nikki. That's really important. Okay, back to you, Ken. Beyond the technical challenges we're all working on, what do you think the workforce in 10 or 20 years is going to look like? And what do you think our biggest challenges and needs for that workforce are?
Well, I asked Bob Gibbs this question a few minutes ago, and he said he had no idea. And while that was a really honest and probably accurate answer, it wasn't very helpful for me. So thanks, Bob. Trying to predict the future is hard, but I think there's a few things that will turn out to be true. I think we're going to need more people. We're going to need more people in technical specialties, and we're going to need a very, very high level of expertise in those people. Going to the moon, going to Mars is harder than I think anybody can imagine. We've been talking about it so long. We see it in science fiction. In science fiction, they're going to stars, right? That are far, far away. But when you deal with the problems every day of trying to go beyond low Earth orbit, it is extremely difficult. So we're going to need the best of what our institutions can produce, of the brightest minds in all of these fields, so that we actually can move humanity from low Earth orbit and out into our solar system.
I'd like to ask if any of the other mission directorates would like to answer that question, since it affects everyone.
I would like to respond to these slanderous comments from Sox. First, kind of accurate. That's not the point, though. That's really not the point. I guess there's something, if we all look back 20 years, you say, okay, predict the workforce, the organization you look into, you think, how accurate would you be? I don't think we'd be very accurate. So I think the question we should be asking, the solution we should be looking for, and I think we're working on this very hard at NASA, is regardless of the mission space, how do we build the process so we can get the best minds working on these problems so that we can identify the capabilities, knowledge, skills, and abilities that we will need going forward. So it's in building that process. Our Chief Human Capital Officer is really attacking this aggressively and looking at this issue from a, well, I can't give you the eaches of owns, but I can give you a process so that we can go out once we identify those things and we can build that sustainable workforce, that incredible workforce that is the secret sauce of NASA, that gets the mission done. So I think that's how I would add some color to what Ken said.
And I would also...
Your microphone. There you go.
Okay, yeah. So it's bad enough I haven't got any voice with no microphone, no one heard me. I also think it's really important that we build an environment that is inclusive. And that, certainly I've always benefited from working in really high-performing teams, and they've always been very diverse teams. And that, but for sure, the best teams are the diverse teams. If you have, everybody that looks and thinks the same, you'll get the same. And as we're doing these really daring, first of a kind, pushing the boundaries, we need to have the best and brightest minds. And so making sure that we have an environment where everybody feels that they see themselves in our teams, I think is just really, really important. And I want to see us really leaning in and doing a lot more of that moving forward.
I agree.
Yeah, I would just add, I think multidisciplinary is going to be really important. I think the specialization in being a structures person or a propulsion person, I think you have to have skills that blend across those, because the design of vehicles are changing. And the skills you need to understand the impacts on other systems, you have to understand how those other systems work. So I think that's a great skill now. I think it's just going to grow as time goes by.
Yeah, what I'd say is this is a phenomenal time to be in our business, probably one of the most exciting times, certainly in my career, and because there's so much activity going on. And if there's something that we need to do to get the workforce for tomorrow, is to have the coolest mission around. Because that attracts people. And then when we do that, that can draw them to the door. But what really draws them in then is if we enable an environment where they can be innovative, when they get responsibility at an early time, at an early age, as a part of their career as they go through this. And if you continue with that, provide mentorship, but give opportunities, I think it's the best thing we do.
Yeah, and I want to call out your early career initiative as an opportunity for people to work on innovative things early in their career and try and experiment and get to grow. I think that's a really important part of what we do. I have to say, I think we have not always been investing in our workforce as much. Over the last decade, we've had a lot of stressors, as most of our government agency partners have, but we're turning the ship around on that. And that's going to be critical, because that is the other aspect of our seed corn as well. I would like to actually ask a couple more questions to talk about. For Jim Free, one of the things that I think we hear about Moon to Mars is, why are we, going back to the moon? We've been there before, but in fact, we haven't where we're going. And so I'm going to ask Nikki to talk about why that's exciting and what we'll find there. But I'd like you to talk about some of the immense challenges of going to the South Pole or having access to the entire moon, and how our architecture is supporting that, which is so different than Apollo.
Right. So getting to the South Pole, our architecture supports it in a couple different ways. The first is the orbit we've chosen for Gateway, the near rectilinear halo orbit, gives us access to the South Pole really in much greater way than we could ever imagine. The challenge, though, when we go to the South Pole is the time when we're going. The lighting is very difficult. So let's say if we miss a launch window, we might miss the landing region or the landing site that we're going to go to. So we have to have some site diversity. How do we get the site diversity? Well, maybe we diversify where we put our habitation elements, so that if we miss a launch window, we can get there, go to a different site, and our equipment's designed to be around for 3 years without maintenance, so we can get to that site and not have to wait until that previous site becomes available. We're trying to build in launch flexibility. Some of our missions, I think until a couple months ago, Artemis 4 had 0 launch opportunities based on what we had to push out there when we were trying to go. We've worked that now with flexibility, things we've learned about Orion from propellant availability. Now we have 70 days that we can launch every year. Our landers are designed to go to the South Pole and to go to the equator, so that there's some science that is required at the equator, so we've built that flexibility into our landers. Our lunar terrain vehicle is going to be designed to be operated as a robotic rover when our crews aren't there, so we can continue to do science. Our pressurized rover will be designed to, if we have to change landing sites, will be designed to go to the landing site where the crew is going to go now that we had to change it. So we've tried to build in the maximum capability to get to different areas of the South Pole to support the science that needs to be done there.
Yeah, it's a staggeringly difficult challenge, and of course Apollo picked a place that they could get to that was relatively easy to get to at the equator, but also had to deal with the communications issues of things like doing your burn to go back home on the far side of the moon when you were out of comms contact. And so there are key parts of the architecture that I think support the safety, but also the resilience of the ability to actually have global access to the moon. But I'd like to turn it over to Nikki to talk about what we'll find there. And I think, importantly, I'd like you to talk about what we know now that we did not know then, and the tools that we have that are going to enable us to amplify the science and do things never dreamed of 50 years ago.
Yeah, I think it's interesting. I often get the question, why are we going back to the moon? And, I often will say, well, don't you want to go to Paris? Yes, but you live on the Earth. Why do you want to go to Paris? I mean, they're very, very different places that we're going to. And just because you've been somewhere doesn't mean that you've really studied it. And the South Pole is very unique. It was quite difficult, and to actually just come down to 13 landing sites. I mean, it sounds like that's a lot, but actually it took a lot of arguing to get it down to 13 landing sites, because there's so many different things and so much sort of diversity on the surface of the moon. But the samples that we'll take from the proposed regions will hopefully provide us to an opportunity to kind of ground truth the effectiveness of our basin ejector modeling. And also to be able to look for the different types of elements, the different things that are there, and then can we actually use them? Can we use something on the moon to actually allow sustainability? And I think they just now with this new technology, I mean, Jim just mentioned really well all the different things that we can do with our landers, with our rovers, maybe with a hopper, how can the different ways that we can do science, and just the exquisite things that we can do with our crew that you can't do with robotics. I mean, we can send robotics into regions that maybe aren't safe for crew to go, or they're too extremes for people to really be able to sort of work in there. But our crew can make those on-the-moment decisions. They can take the sample that they can actually choose between samples that if you just have a robot, you say, well, we're just going to take the sample here. You've actually got crew that can say, that's a really interesting sample. And so there's just really defining the science that we're going to do. Going back to the moon, I think, is absolutely amazing. And going back to sort of stay is incredible. And I'll just also note, I really appreciate Jim for saying that we also want to do science at the equator. And it's not easy to do science in both places. It's, while the moon looks small from down here, it's really quite big. And they're quite different. So really appreciate that there's also in the planning how we can do science from all of the regions that we really want to do it from.
Well, thanks for taking leadership, and thanks to your Deputy for Exploration Science, Joel Kearns. I find it remarkable how much science you get done on the surface of Mars with how many watts of power?
Very few.
Very few.
Very few.
And then, of course, the space station, by example, generates more than 110 kilowatts of power. And so when humans come, we bring power and we bring data. And in addition to that, all the computational tools that have evolved over years and that we've made technology investments in that I think are going to be transformational for science. So I'm excited about that. Jim Reuter, I'd like you to talk for a moment about how the infrastructure that we are working on and hoping to partner with is going to enable our industry partners to develop new business models.
Yeah, thank you. A key part of what we try to look at of how we work on technologies that would lead towards us having a sustainable presence on the moon, a key aspect of having a sustainable presence is we have to have a community that's brought along. And what we have to do is enable enough of the technologies so that there's a broad community that takes the next step beyond us. So we're not the only customer. We may be an important customer, but we're not the only one to go forward. And so what we have over the next decade or so have in our plans is to start with a series utilizing the CLIPS landers, the commercial landing program that science runs, as well as then as we get space on the human landers as well. But use those platforms to demonstrate technologies incrementally. And so we have, in fact, late this fall on the Intuitive Machines second mission, we have a number of technologies there that we'll demonstrate. It will be the first time demonstration of a drill to look for water. That same design of the drill, a different copy, will go on the Viper mission that science has. And so it'll be our first demonstration of it and help get it ready so we know how to operate it by the time our big mission comes along. We also have on this mission what we call a hopper, or what's called a hopper by Intuitive Machines. And these are all partnership missions, as we go through it. And so that allows us to hop, about a mile at a time across the surface as we go through it and have instrumentation as it goes along. And then the final key area there is really a wireless network demonstration on the moon. And then as we look through, as you look through our President's budget request, we have a series of missions that arise that will develop mid-20s, late 20s, and into a ISRU power plant demonstration. And we're still refining that, but it's things like excavation and construction demonstration, recovery of oxygen from the soil and the minerals and metallics that come with that. Recovery of water, one of the first demonstrations we have. So our goal is to get there and get power that goes with it, so that by the time we get towards the end of the decade, we've demonstrated enough technologies to select what do we want to do for our pilot plant, and then let's introduce more power with a fission surface reactor. And at that point, then, our goal is to have done enough activities jointly with industry that there's a lot more they can take over on their own interests and with their other partners as we go through it.
Great. We are slightly over time, but I want to give Sox the last word. I just want to ask you, our three pillars, which are science, national posture, and inspiration. We've talked a lot about the first two. Tell us about the impact of the naming of the Artemis crew on the Artemis generation.
Well, I hope that when the young people out there today see the Artemis II crew, they can see themselves. I know back when I was young, I saw the Apollo astronauts, and I could see myself in one of those missions. The Artemis II crew should give us an even broader group of folks that can identify that way. And I hope they'll realize that there's a place for them in what we're doing. Going to the moon, going to Mars will take everybody in our society to participate and support. And I hope everybody saw that when we named that crew.
Thanks, Sox. Hey, everyone. Are these the most amazing senior leaders an agency could ever have? Thank you. Thank you so much.
Thank you, panel. This was an exceptional dialogue. Some exciting times lie ahead on the road from Moon to Mars. Please join me in a round of applause for our panelists. HII, Huntington Ingalls Industry, is a first-time sponsor at the Space Symposium, supporting our exhibitor solutions. General Buck, we look forward to your panel.